Section 12.3, we are going to talk about Newton's laws of gravity or Newton's laws of motion. Now remember, when we were talking here earlier in 12.1, what's the unit of force? The unit of force is called a Newton. Well, the reason we do that, right, the reason we do that is simply because of the fact that Newton is so involved with force. All right, he studied force, he studied how planets move, he studied how planets interact, and he really got this idea of force and mass and acceleration and combined them all together. So in honor of that, we gave the unit of force, we named it after Newton since his work was so promising in the field. Now, when Sir Isaac Newton worked on the laws of gravity, the laws of motion, he came up with 3 laws of motion or 3 laws of gravity. And the first law is this: an object at rest stays at rest. Well, think about that. If I set down a water bottle on a table and no one touches it, it's going to stay at rest forever, right? An object in motion is going to stay in motion, right? Think about that. If I throw a tennis ball, hypothetically, it should stay in motion. So if you think about it, if I throw a baseball, that baseball is going to stay forever in motion unless, here's the big unless acted upon by an outside force. So on planet Earth, what is stopping that baseball? Gravity and friction, right? The ball slowly slows down. I don't throw a baseball, it doesn't go on forever. However, if I took out gravity and friction like in outer space, and I threw a baseball in outer space, it would stay in motion forever unless acted upon by an outside force, like it hits another object or comes into the gravitational field of another planet. Same thing at rest. Something's always going to stay at rest until something makes it move. What makes it move is an outside force. So, Newton's law of gravity, the first law, an object at rest will stay at rest, an object in motion will stay in motion unless acted upon by an outside force. He has 3 laws. We covered the first one. What is the second one? Newton's second law. The acceleration of an object is equal to the net force acting on it divided by the object's mass. What the heck? Guys, Newton came up with a math equation for his second law. And that second law, what's key about that second law is right here. Force is equal to mass times acceleration. F equals force, m equals mass, and A equals acceleration. Now, if we're talking about the units, what's our general unit for force? Newtons. What's our unit for mass? We prefer using kilograms. And what's our unit for acceleration? Meters per second squared. So, we have force is equal to mass times acceleration. Now, if we go and circle this, create a circle for this one. Right? Force is equal to mass times acceleration. If you need to solve for acceleration or mass, you're going to simply divide. So let's do a real life word problem here. A baseball weighs 0.25 kilograms. And I'm able to throw it at 20 meters per second. A baseball weighs 0.25 kilograms, and I am able to accelerate it at 20 meters per second squared. What is the force in which I have to apply that baseball to do that? So, let's go through here. We have force, question mark, mass, question mark, acceleration, question mark. Let's go through my word problem here and figure out what we have. A baseball has a mass of what? Do you guys remember? 0.25 kilograms. And I throw it with an acceleration of what? 20 meters per second squared. What is the overall force in which I throw that baseball? Well, we're going to cover up force. Force is equal to mass times acceleration. That's equal to 0.250 times 20. And our force is going to equal, and when we take 0.25 times 20, we're going to get 5. Now, how many sig figs should we have? 1. 1 sig fig. Our unit for force is newtons, and our answer is 5 newtons. Now, you'll find out that force, sometimes it does not take a lot of force to do things as often as you would think it does. So sometimes forces will be really low, sometimes forces will be really high. Now I kind of made two numbers up on the fly. That's a realistic number for the mass of a baseball. That's probably not a realistic number for the acceleration. It's probably much higher than that, but you kind of get the idea of how we're going to use Newton's second law. The force is equal to mass times acceleration, and how we're going to apply it. So remember, force is always in newtons, mass we prefer kilograms, and acceleration is meters per second squared. But Newton's second law is force is equal to mass times acceleration. Lastly, we need to talk about Newton's third law. Newton's third law is this: for every force, there's an equal and opposite force. So think about this. For every force, there is an equal and opposite force. What happens here? All right, you're playing basketball, you go up for a layup, you get fouled. You fall to the floor, you hit your head on the floor. Your head hitting the floor is the initial first force, right? But there is an equal and opposite force. The force, all right, the floor gives a force back. Right? When the floor gives a force back, what does that happen? What does that cause? That causes your brain to move around in your skull a bit and hit your skull. All right? And that's kind of how concussions happen. If you think about it, it's that equal and opposite force. The floor giving you a force back. Your head hits the floor with a force, but the floor also gives that force back. And in doing so, your skull is going, or your brain's going to vibrate or move against your skull. When it does that, that's going to result in concussion. So for every force, there's an equal and opposite force. So Newton's three laws. Number one, an object at rest will stay at rest. An object in motion will stay in motion unless acted upon by an outside force. That's number one. Number two, force is equal to mass times acceleration. And number three, for every force, there's an equal and opposite force. Those are Newton's three laws. This is the end of section 12.3. This is Mr. Kleinert, and I'm signing off.